everyone. Okay, this is second session on compaction. We are going to study much more in detail about the compaction. Already we have done one lecture. Okay, compaction of soils. As far as your syllabus is concerned, these are the points to be covered. Compaction of soil. So what all you have is definition, principle of compaction already covered. Then standard and modified Proctor test. We have already covered standard Proctor test. Modified Proctor test is having more of energy. I'll discuss it. Effect of compaction on soil properties. That is what is the major point of discussion in this particular session. Okay, other things we'll cover in later stages. Okay, of course I'm going to use S.K. Prasad's notes. Of course that is available in the net also. So this is what is mechanism of compaction. You have seen it in the beginning. If you have taken quite dry soil and then if you put some effort of dropping that 2.5 kg rammer 25 times on each layer, and then it is compacted in 3 layers, you'll be getting some dry density, right? And then if you add a little bit of water, that helps in compacting the soil in better manner. Because of that, though the soil particles are remaining the same, the volume has decreased, right? If you put more of water, still there will be a reduction in the volume. Because of that, what increases is dry density. So what we are plotting is dry density, because water will not be a permanent, it gets dried also. Because of that, particles, soil particles which will be compressed in particular volume will be leading to dry density. So after a particular stage, even then also if you add more of water, it increases the volume of the soil. Because of that, again dry density drops down. That is what we have studied as mechanism of compaction. Okay. So what are the factors affecting compaction? Factors affecting compaction. Now, water content. As I have told you, as you go on increasing the water content, the dry density increases, like that, right? So that is first simple point. Amount of compaction. More and more compaction means this whole test is being conducted by standard Proctor test. Then what is done is, when you change the water content, you will be compacting with the same amount of energy. The energy we have seen in the last class, that is 3 layers, 25 blows on each layer, and then that will be 2.5 kg rammer falling through a height of 0.3 meters. So like that, every time when you compact the soil, you are putting the same amount of energy. Suppose instead of 3 layers, if you use 5 layers, and then instead of using 2.5 kg, if you use more mass rammer, then the effect or the dry density achieved and then OMC achieved will be different. So as our simple statement what I can make is, as you increase the compaction effort, what happens is this OMC decreases and then dry density increases. If I have to draw a modified Proctor test diagram on the same thing, it would be something like that, indicating that the dry density or the OMC has decreased and then dry density has gone up, right? Because on this axis you are plotting dry density, right? So that's how it becomes, right? More the compaction effort, lesser the OMC, higher the density, higher the dry density. That is what is the point. Now, method of compaction. There are a lot of methods we are going to study. In laboratory, we have got only two, that is standard Proctor test and modified Proctor test. But when you go onto the field, there are number of ways. You might have seen rollers rolling the soil, but there are variety of rollers, and then there are other ways of compacting soil that we'll be discussing in detail. Right? Anyway, method of compaction matters. It affects how the soil is getting compacted. Now, type of soil, that is whether it is a granular soil like sandy soil, or it is a clayey soil or a silty soil, that will be affecting the compaction achieved. Compaction achieved in the sense dry density achieved. Okay. Addition of some admixtures means if you add some chemicals and then try to compact, obviously they will be having their own effect, because generally admixtures will be playing a role of plasticizer, in the sense the particles will be getting smoothened. So when you apply compaction effort, obviously they slip one on the other, and then they will be getting in more compact manner. So the factors which will be affecting compaction are water content, amount of compaction energy, method of compaction, type of soil, and then addition of admixtures. Okay. Effect of water content. This is nothing but the same thing just now whatever I have told you, which is discussed in principle of compaction, that you can read and see. Right. So all these points I have covered in earlier lecture also. Will not be spending much time on that. You can have a look of those points. Okay, here factors affecting compaction already we have done. Effect of amount of compaction, that's what we are going to study here. As discussed earlier, effect of increasing compaction effort is to increase MDD, that is maximum dry density, and then reduction in the OMC. You can just see here this brown line, if you take, it will be having one amount of energy. Now, as I have told you, in standard Proctor test we have put 3 layers in compaction. Suppose if you increase the number of layers, 4 layers, and then every layer is rammed with 25 blows, then the kind of curve that you may get will be something like this, orange. Right? Now increase the number of layers to 5, let's say. This is one way of increasing the effort. Now if you go on doing that, you'll be getting this. So not necessary that you have to increase the number of layers only. Instead, you keep the number of layers same, but if you increase number of drops, we have said that 25 number of drops. Instead of that, you make it as, let us say, 40 number of drops for every layer. Then 3 layers only, but every layer you are ramming 40 times. Because of that, the amount of energy is increased. Or one more way is you increase the fall height, that is 2.5 kg is falling through a height of 30 centimeters, 0.305 meters. Now if you make it to drop for 40 centimeter or 50 centimeter, the same 2.5 kg rammer, then obviously you have increased the effort, compaction effort. Still one more way is instead of having 2.5 kg, if you have 4.5 kg, 5 kg, 10 kg, like that, if you have a big rammer, then obviously though you are keeping everything else same, that is 3 layers and 25 blows, you have increased the amount of energy used. Right? So in whatever way, whether number of layers, the weight of the rammer, number of drops, all those things will be leading to increasing the energy. And if there is an increase in energy, then the curve that you will be getting will be something like that, more and more, so that it will give you higher MDD, higher maximum dry density, and lower OMC, right? What is the other point? However, there is no linear relationship between compaction effort and then, yeah, this is not linear. The trend is like that, but you cannot just relate the compaction effort to MDD. That is what the point has been said. Okay, effect of type of soil. You can just see here uh, higher and higher energy, it is going that way, the curve is going that way. Now in this case, this is the different type of soil. Maximum dry altitude depends upon type of soil. Okay, so effect of type of soil depends upon the type of soil. Coarse grained soils achieve higher density at lower water content. Yeah, here you can just see, here we have put the names of the soils also. Well graded gravel, well graded sand, silt with low compressibility, clay with low compressibility, clay with higher compressibility. Okay, now here if you go on to smaller and smaller particles, right, what has happened is the water content OMC achieved is larger, because if you just compare this clay and then this gravel, the OMC is here, right? I'll just put a line. Okay, OMC is there for gravel, OMC is over here for clay. So if you compare OMC of gravel, it is quite less compared to OMC of clay. So general statement is clayey soils will be having higher OMC. Clayey soils will be having higher OMC. And then if you compare the dry density achieved, now look at that, dry density achieved, here also the dry density achieved. Now here what is happening is, obviously the dry density achieved for gravel is more, and then dry density achieved for clay is less. Alright, so this is what is the effect of different types of soil. So what you have to do is maximum dry achieved depends upon the type of soil. Coarse grained soil achieves higher density at lower water content, and fine grained soils achieves lesser density. Okay, that is the effect of type of soil. Okay, influence of compaction on different soil properties. This is what I told you is the major emphasis has to be on this on today's lecture. What are the properties I have listed? Just check. There are 1, 2, 3, 4, 5, 6. So density is there, shear strength is there. These are the properties. Permeability is there, bearing capacity is there, settlement is there, soil structure is there. For every one of them I have made a statement. Density, it is obvious, this results in increasing the dry density of the soil. Obviously as you go on increasing the compaction, or just you compact the soil, what happens is there will be increase in dry density. Okay, the shear strength, in general effect of compaction is to increase the number of contacts, resulting in increased shear strength. Okay, because soil particles will be getting compacted, means getting closer and closer, more and more soil surface will be coming into picture for resistance. Because of that the soil's shear strength increases. Permeability, when you compact the soil, you are removing the voids, or void space is lessened. Because of that there will be obviously a reduction in the permeability. Bearing capacity, the soil when gets more shear strength, obviously it will be having more bearing capacity. Bearing capacity increases with increase in compaction. Settlement, compaction results in reduction in the reduced settlement, obviously because already it has get completely compacted. Because of that there won't be any or hardly there will be any settlement. Soil structure, we have not studied at soil structure, but anyway you can just go through. Soil structure is whether it is particulate structure, as in case of sand and gravel, or is it amorphous lumpy kind of thing in as in case of clay soils, right? In fine grained soils, in fine grained, you can understand the word fine grained soils. On dry side of the optimum, you know this word also, on dry side of the optimum, because we have seen that when you have a curve like that for compaction, here there is a maximum dry density. This side is known as a dry side, and this side is known as wet side. Okay, so dry side of compaction, the structure is flocculated. We'll be studying what is this. The particles repel and density is less. Addition of water increases lubrication and transforms the structure into dispersed structure. Because of that, particles come closer, right? And then in coarse grained soil, the single grain structure is maintained, whereas in composite soil, behavior depends upon composition. So there are 6 properties, and then you should be able to make a comment on each of these properties. Okay, here again we'll discuss the same old problem. We had left off a bit of part there. I'll discuss in this part. Okay, this problem already we have seen. The volume is given in 1 into 10 raised to 6 millimeter cube. You might have worked out this. You can convert it centimeter cube. It will be easy to handle. It will be 10 raised to 3 centimeter cube, right? Or you can convert this into meter cube also, right? Okay, the calculation part is like this. Last time I have shown you, right? Okay, here there is that particular graph. Okay, now bulk density, I had written this gamma B, it is, and then water content is W, water content is W. The dry density is gamma D, and gamma D is given by 1 minus Na G gamma W divided by 1 plus Wg. The basic gravity of soil solids is known, then W, the water content, is known. Then we can directly calculate gamma D with this, the percentage of air voids, right? Now look here, percentage of air voids, Na is nothing but volume of air voids divided by total volume of voids. Okay, now if you look at this figure, here there is a little less of water, water is increased, and so on. Now only with this much of amount of water, if the soil gets saturated, in the sense these voids are not there, so to say, right? And we have removed all the air voids, and then if we say only the volume is this much only, right, from top of this water up to this bottom, right, these air voids are completely removed and volume is only this much. Obviously what happens is dry density will be maximum, because this volume we are removing, right? It is weight of soil solids. What is dry density? Gamma D. I have written last time number of times, the same thing I am going to write once again. Gamma D is equal to weight of solids only divided by total volume. That's important, right? So in this case, if you take weight of soil solids is so much and then volume is so much, volume which is there in the denominator is more, in the sense gamma D will be less. That's why it is somewhere there, right? Now what I am trying to tell you is, here there is a reduction in the volume, but weight of solids is remaining the same. But one more thing that is getting added here is, suppose this air is completely removed and with this much of water only it is fully saturated, in the sense no air voids are there. That is percentage of air voids, if you make it 0, if you make it 0, then what happens is this becomes 1 and this becomes G gamma W, this G gamma W divided by 1 plus WZ. So that's why it is called zero air wide line, gamma D of zero air wide line. Obviously this with this water content, this gamma D shoots up somewhere there, let us say, and then when you increase the water content, right, with more of water it is again fully saturated, so the volume is slightly increased. You can see that though the particles volume is remaining the same, right, now amount of water was only so much, now it is increased. Because of that the total volume has increased, reducing the gamma D, right. Assumption is there is no air voids. So what happens is this value with this much of water content will be coming somewhere there, let's say. So this story continues. So as you go on plotting the gamma D values with an assumption that air voids is 0, air voids is equal to 0, right. So this leads to this equation, and this will be giving you gamma D with 0 air voids. Then what happens is, you can observe here all the values are continuously decreasing, there is no increase. That's why you get a curve or something like that, right. So it's an imaginary curve, it is an imaginary curve where we are assuming that air voids are completely removed and with whatever water content it is fully saturated, right. With that assumption, when you do it, this is called zero air void line. But suppose if I assume 5% of the air voids or 10% of the air voids, then rather than this equation you have to use this, right. Here you can substitute 5% in the sense 0.05, so there will be a multiplier of 0.95 for these values, and you will be getting rather than ZAV, you can say that it is 5% air void line or 10% air void line. Like that you can go on plotting any percentage of air void lines. And one more thing that you should observe is always zero air void line will be much above this actual behavior of the soil, because it is an imaginary, right. It will be giving you more value of gamma D. So this zero air void line will not be cutting this, right. What I mean is, when you plot the zero air void line, it will be always above like that. It cannot cut, right. You cannot get a curve something like that. So that is what is important thing to be remembered. Okay, here they have plotted curve, right. So simultaneously you have got a compaction curve also, as well as so with a water content of 10% here, the dry density achieved is 17.5, whereas gamma D ZAV is 20 point something, right, 20.83, there it is. So with 12% actual is here, imaginary ZAV line is there. So likewise when you go on drawing it, so this is what is ZAV line, or gamma D with zero air void line will be something like that. Okay, I think with this we'll stop today. We'll discuss more things in the next class. Okay, thank you.